Bismillah ar-Rahman ar-Rahim. Our lecture today is the continuum of laboratory procedure in removable partial denture constructions. We start with duplicating a stone cast. The stone cast may be duplicated for several reasons. Number one, preserve the original one. The original cast, the master cast, should be preserved. Second, fitting a removable partial denture framework without the danger of a fracture or abrasion of the original master cast. So, we duplicate the stone cast for the purpose of fitting removable partial denture framework. Number three, allow an investment cast to be formed for the fabrication of the metal framework. We used the duplication procedure in order to allow the opportunity for the formation of investment cast or refractory cast to be formed for the fabrication of metal framework. In this picture, we have two figures. On the left, we have the master cast. On the right side, we have the duplicated cast or refractory cast. Careful preparation of the master cast for the production of the investment cast or refractory cast involve consideration of the number one, defined path of insertion. We should preserve the definite path of insertion and removal of the removable partial denture. Number two, preservation of the height of contour, the maximum height of contour or the maximum convexity of the cast. Number three, the retentive and stabilization areas designed during the mouth preparation. We should preserve all these areas that has been detected on the master cast. Now, this is the stone cast with all the additions that has been done during the previous steps of the relief and blockout, ready for duplication. Now, when we start discuss the duplication procedure, we have the duplication materials and we have duplication flask. The main materials and the usual material used for the purpose of duplication, we have the colloidal materials are made fluid by heating and they return to the gel condition or consistency upon cooling. So on the left side we have the colloidal material, on the right side we have the silicone material that used for duplication also. Now, during duplication, the stone cast to be duplicated must be placed at the bottom of a suitable flask. This suitable flask is called the duplicating flask. Care must be taken and caution should be taken that the temperature of the duplicating material is not higher than that recommended by the manufacturer instruction or recommendation. Why? To prevent melting and dissolution and distortion of the blockout material on the stone cast. So, if we want to make an impression for the stone cast, to make that impression, the blocked out master cast ware is placed on the base or the bottom of the duplicating flask and the flask component assembled. So, this is the duplicating flask. Here we place the blockout master cast placed at the base of the duplicating flask. Then duplicating flask is assembled and closed, ready for the duplication procedure. After assembling of the duplicating flask, a steady stream of the reversible hydrocolloid is poured into the flask. When it is made in fluid consistency, it is by heating, it is poured where? In the flask. Once we fill the flask with the duplicating material, the flask is placed in a regulated cooling tank up to about 1 hour or 60 minutes, which is the time required to fully set the colloid material. So we place or we bring a boiler for melting the reversible hydrocolloid duplicating material. The reversible hydrocolloid is melted by the temperature. We pour this reversible hydrocolloid ware into the duplicating flask assembled. After the set of the duplicating material, the flask is disassembled. We open the flask. The master cast is carefully retrieved and removed with the aid of two knife blades, engaging the sides of the cast. So we remove the flask. Is removed as we saw in this picture. We remove the flask. Then carefully we remove the master cast from the duplicating material. When we remove the flask, the result will be a space. This space is a mold cavity ready for pouring the investment material in order that we will get at the final step the refractory cast. So we have here important notes. The duplicating colloids or reversible hydrocolloid can be repeatedly reused. Why? Because it is reversible. So by special equipment we use to remelt and then store the colloid. To employ such technique, the clean colloid material cut into small pieces and then heated in a double boiler until the material reaches fluid consistency. The solution is then allowed to cool at the working temperature, ensuring a suitable flow of the material for the purpose of duplication, but without melting the blockout wax on the master cast. The breakdown temperature of 100 degrees centigrade, 212 Fahrenheit is the breakdown. The working temperature is about 63 degrees centigrade, 145 Fahrenheit is suitable for most of the duplicating materials. So the duplicating material, if it is clean, it can be used again and again without discarding. So this is clean colloid material cut into small pieces. Again, we heat it in the boiler and the material reaches fluid consistency. We poured it again in the duplicating flask if we want to use the material again or for another duplication procedure. Because it is reversible, it can be reheated and resolidified. Now, the other step is the formation of the refractory cast. Refractory cast is made from refractory materials. The refractory material, sometimes termed investment material. The investment material formed by special powder and liquid, measured and mixed together according to the manufacturer instruction in order to reach the suitable consistency. There is an important criteria for the refractory cast. In the refractory cast, or in the investment material used for the construction of the refractory cast, there is mold expansion. This mold expansion is accepted to match the shrinkage of the associated casted alloy. So the investment material is allowed to harden before removal from the mold with the expansion that is expected to occur during the setting of the investment material. This expansion will compensate for the shrinkage of the casted alloys during construction of the removable partial denture metal framework. So, the steps of construction of the refractory cast: the investment material, after reaching the suitable consistency, is poured into the mold space made by the investment material, or duplicating material. The investment material, after it is poured inside the duplicating material. Material is allowed to harden and to reach the acceptable amount of expansion. Then, after the setting of the cast is removed from the mold. Now, this cast is called the refractory cast. This cast is not the stone master cast. It is the refractory cast, which we use it for the construction of the metal framework. Now, the duplicated model or cast is allowed to dry. How? By placing it in a drying cabinet or drying oven. After that, the refractory cast is dipped in a hot beeswax. Why? To ensure a dense, smooth surface and to eliminate the possibility of the need for soaking the cast before the investment procedure. So, in this procedure, the refractory cast is removed from the dryness cabinet. The refractory cast here is dipped in hot beeswax. Now, as we saw here, the refractory cast is allowed to dry. We saw the surface of the refractory cast is made smooth and dense, and this is the requirement for the surface of the refractory cast. Again, we repeat, the refractory cast is made from the investment material after we pour it in the duplicating mold. Now, waxing the framework, or we start the procedure of making the wax pattern for the framework. Before we start waxing, the design drawn on the master cast must be transferred exactly from the master cast made from the stone to the refractory cast made from the investment material. Every effort should be made and done to precisely and correctly transfer the outline of the metal framework to the refractory cast from the stone cast. During the design transfer procedure, care should be exercised or taken to draw the design of the removable partial denture with a minimum of pressure, so the surface of the refractory cast is not damaged or scratched. The position of the individual clasp tips is the most critical part during the transfer procedure. So during the relief and blockout, if appropriate ledge were created and formed during the blockout and relief procedure, the placement of the retentive clasp tips is much easier and more precise and correct. Now, after completing the wax of the or metal framework waxing, we start with sprueing. Sprueing, what we mean by procedure of sprueing, a sprue channel by definition is the opening. This opening is lead from the crucible former to the cavity of the metal framework. In this cavity, the framework is to be casted. So, the sprue mean a piece or the channel made from wax that allow the pathway for the entrance or connecting the crucible former, which is pink in color in this picture, triangular pink color, where to the metal framework wax up, which is made on the refractory cast. So, by general rules for sprueing, the sprues should be large enough that the molten metal in the sprue will not solidify earlier until after the metal in the casting framework has frozen. So it is preferable that the wax or round wax made for the sprue should be on the gauge between 8 and 12 round wax is usually used in case of multiple sprueing during removable partial denture casting. Another rule is that the sprue channel should lead directly into the mold cavity as direct as possible and still permit the formation of configuration that will induce minimal or no amount of turbulence or disturbance in the flow stream of the molten metal during the casting procedure. Also, the sprue should leave the crucible former, as we saw here in the pink triangle, from common point. I mean, there is connection point and attached to the wax pattern of the metal framework in the region of the bulkier section. The result of these two requirements is that no thin section of the casting should intervene between two bulky unsprued portions. That means that we will ensure uniform distribution of the molten metal during the casting procedure of the metal. Now, investing the sprued pattern. When we complete the sprueing of the wax pattern, this wax pattern should be invested by investment material. The investment material must conform accurately to the shape and design of the pattern and must preserve and contain the configuration of the wax pattern as a cavity after the pattern itself has been eliminated through the vaporization and oxidation. What does it mean by this? When we make investment or investing the sprued pattern, as we saw in this two figure, we saw here that the wax pattern has been sprued. The crucible former in the left figure is red in color. In this case, we made investment material in all critical portion of the wax pattern. After that, we totally invest the wax pattern with the investment material. Now, what is the purpose of the investment material? Why are we investing the wax pattern? The investment material provides the strength because the metal need strong investment material during casting. So the investment material provides the strength necessary to hold the forces exerted by the entering flow stream of the molten metal until this metal has been totally solidified in the form of the wax pattern in order we reach the metal framework pattern. Also, the investment material, as we know, provides a smooth surface for the mold cavity so that the result is that the final casting will require as little finishing as possible during finishing and polishing procedures. Now, also, the investment material provides an avenue or pathway for the escapement of most of the gases created and entrapped into the mold cavity by the entering stream of the molten metal. It means the investment together with other factors to provide the necessary compensation for the dimensional change of the alloy when it is changed from the molten state to the solid state or cold state. So, it will compensate for this dimensional change. Now, the first step during metal casting is the burnout procedure. Burnout has three reasons. Number one, burnout is done to drive off or remove all of the moisture in the mold. Moisture where? In the mold. The mold is created from the investment material when we invest the wax pattern. Number two, the burnout will evaporate and eliminate all the wax pattern. When the wax pattern of the framework of removable partial denture is evaporated, there will be a cavity inside the investment mold. Also, the burnout, as a result, will expand the mold. This expansion, heat expansion, will compensate for the contraction of the metal upon cooling from the molten state to the solid state. So the burnout is done by holding the mold and placing it in the oven, burnout oven, with the sprue hole directed downward in order to eliminate the wax pattern. The temperature should be maintained inside the oven for the recommended or acceptable period of time recommended and advised by the manufacturer. Why? To ensure uniform heat penetration to the mold. After the burnout, we start with the casting procedure. Casting is the process by which we quickly injecting metal, molten metal, into the mold cavity. What we mean by mold cavity? The cavity that were created after the burnout procedure of the wax pattern. The force of the injection of the molten metal may be centrifugal in nature or air pressure. In any case, too much or too little pressure is undesirable and unaccepted. Why? If too little force is used to push the molten metal into the mold will not fill totally before the metal is start to freeze. So we will get areas of defect in the metal framework. If too much force is exerted during casting, excessive turbulence may be resulted and there will be entrapment of gases and air bubbles in the casting, again leading to defect. So during casting procedure, we place the metal inside a special equipment for the purpose of the casting. So we place the metal inside this equipment and we start heating it by special flame in order to make it melt. By the effect of the temperature, the metal is starting to melt and converted from the solid state to the metal state. The metal is now become ready to be injected and shotted into the mold cavity as quickly as possible. When the casting procedure is completed, the mold is removed from the casting machine and allowed to be cooled by special time and device according to the manufacturer instructions and recommendation. The casting recovery procedure means after the appropriate time, we remove the mold or taking the mold, the outer layer of the refractory or investment material is removed by tapping it with a mallet. We break the outer layer carefully by careful tapping with a mallet. After that, the remaining investment material in the critical area is then removed by airborne particle abrasion, where in a self-contained machine. That means there is a machine specially manufactured for the purpose of airborne particle abrasion. So airborne particle abrasion device is ready for making abrasion and removing of the remaining investment material from the metal framework. So in this figure we saw that the remaining investment removed by airborne particle abrasion. The casting here after the finishing of the abrasion material is ready for the other steps of the manufacturing. Subsequently, the casting in here is examined for any defect, any deficiencies, any errors. If the casting is regarded satisfactorily and acceptable, finishing procedure and fitting could be started. So finishing the framework, we start with sprue removal. Sprue removal is done by using high-speed lathe machine and large abrasive disc. The sprue leads and sprue connection with the metal framework are cut from the casting because the sprue is not included in the design of the metal framework. We start with rough finishing and then shaping before fitting the framework to the master cast. The following are several rules for finishing. High speed is preferable than low speed during the removal of the sprue and sprue entrance and sprue connection in the metal framework. We use different types of wheels or point are used, and the speed of their rotation should be adjusted for the purpose of cutting and removal of any excess and metal flashes from the metal framework. We should use definite sequence of the finishing procedure should be adopted and followed for every part of the metal framework: major connector, minor connector, clasp tips, and denture base layer. After that, we start with polishing. We use clean polishing wheels should be used for the purpose of the polishing of the metal framework. After that, we should be totally sure that each finishing and polishing would entirely remove all the scratches and all unacceptable metal slashes remaining in the metal framework. And then, after that, we start with fitting the framework. The framework or the fit of the framework is checked by seating the casting on the master cast carefully and attempt to identify any areas of interferences, any areas that prevent the complete seating of the metal framework should be checked and removed. Here is the reference for our lecture. Thank you for your kind listening.